We will conclude section 6.3 by discussing other relationships that exist between our trigonometric functions. We're going to begin with the idea of a cofunction identity. A cofunction identity depends on having two angles that are complementary to each other. If you recall from a geometry class, complementary angles are angles that add up to 90 degrees. So, for example, if we have angle alpha and we have angle beta, and if those two angles add up to 90 degrees, or those two angles add up to pi over 2 radians, then they are said to be complementary angles. So, as we define a cofunction identity, we will see that term complementary angles. So our definition says, given an angle theta measured in radians, pi over 2 minus theta is the measure of its complement. Now, sometimes that is confusing to students the way that is worded. What that essentially means is that if your two angles, if theta is one of your angles, and pi over 2 minus theta is the other angle, that when you add these two angles together, you get either 90 degrees or you get pi over 2. And you can see that because the thetas will cancel out. You have a positive theta and then you have a minus theta. And so these angles are going to equal pi over 2 when you add them together. And so therefore, theta and pi over 2 minus theta are complementary angles. They add up to 90 degrees or they add up to pi over 2. So if that is the case, if you have two angles that are complementary to each other, then you have this relationship that we refer to as cofunctions. And so essentially what that says is that sine and cosine are equal if your angles, one angle is the theta and one angle is the pi over 2 minus theta. Similarly, you have a cofunction relationship between cosecant and secant. You have a cofunction relationship between cotangent and tangent. So what that means for us is that, say for example, cosine 40, we would know that that is equal to sine 50. We have the cofunction relationship between cosine and sine, and we have two angles that add up to 90 degrees. Or if we were looking at our second one, we could say cosecant of, and I'm going to make up another angle, like maybe 10 degrees, would equal secant of what angle? 80 degrees. Good, because the angles have to add up to 90 degrees, and the functions have to maintain the cofunction relationship. Similarly, on the tangent and cotangent, you could have, say, cotangent of pi over 6, moving to a radian measurement, and you know that that would equal tangent of pi over 3, because we know that pi over 6 is your 30 degrees, and your pi over 3 is your 60 degrees. And so 30 and 60 make 90. So in order to use cofunctions, you have to have two conditions being met. You have to have angles that add up to 90 degrees or angles that add up to pi over 2 if you're dealing with radians. And you have to have the pairing of the functions to represent the cofunctions. We're going to come back to this in just a minute and do some examples. Another relationship that we're going to investigate in this section is the reciprocal identities. These we've already discussed. We discussed these when we talked about defining the trig functions, and we've discussed them several times since. This is the relationship that says sine and cosecant are reciprocals, that secant and cosine are reciprocals, and that cotangent and tangent are reciprocals. And so, although the notation here is somewhat mathematical, all we're saying when we see something like this is we are defining the relationship between cosecant and sine as being reciprocals of each other. And it's worth noting that we could write it as they've written it on the slide, but we could also write it as sine theta is equal to 1 over cosecant theta. And that is the same identity. It simply establishes that relationship between these two functions as being reciprocals. And the third thing that we're going to look at in this section is what are called quotient identities. And these are two formulas, one formula for tangent and one formula for cotangent. The one for tangent says that tangent is equal to sine over cosine. And remember that cotangent is the reciprocal of the tangent. So if tangent is sine over cosine, then it makes sense that cotangent is cosine over sine. Okay, so let's look at some examples. We're going to start with the cofunction idea, and we are asked to express an equivalent cofunction to each of the problems that are given, and then verify that they're the same based on what we would get with our calculator. Okay, so remember, I'm going to go back to our screen for a second. Remember that cosine and sine pair up as cofunctions. So I know that this expression is going to equal the sine of some angle. And I also know that when I add the two angles together, I need to get pi over 2. All right, so let's figure out what the angle has to be. So in other words, if I take 5 pi over 11 and I add, and let's use a variable, let's just call it theta, then we're supposed to get pi over 2. And so we need to figure out what the theta has to be. All right, so I can do that by adding 5 pi over 11 to both sides of this expression. Now we know that we'll have to do a common denominator over here to add. So we could write pi over 2. Let's write it with a denominator of, I guess we're going to have to use 22 as our common denominator between 2 and 11. All right, so 2 goes into 22 11 times, so we would need 11 times pi on the top for this one. 11 goes into 22 2 times, so 2 times 5 would be 10 pi on the top for this one. And adding those two together would give me 21 pi over 22. They would cancel on this side, and that would solve the expression for theta. So these two expressions should be equal. All right, so let's check and see. So I'm going to pull up our calculator. All right, so I'm going to enter these two expressions in my calculator. Be sure that your mode is set to radians. All right, so I'm going to do cosine of negative 5 pi divided by 11. And I'm going to get an answer for that. And then I'm going to enter in the sine of 21 pi divided by 22, and we'll get an answer for that. And we should get the same answer, showing that that cofunction relationship holds in that these two are equal. Okay, so let's look at our second example. Our second example has cosine 195 degrees, cotangent 195 degrees. And so what we want to do is say that the cotangent and the tangent match up as cofunctions. And now we want to consider what the angle has to be. And again, we know that the angle has to add with 195 to make 90 degrees because those angles have to be complementary. So 195 plus some unknown angle is equal to 90 degrees. So we're going to subtract the 195 from both sides. And that tells me that my new angle is going to equal negative 105. And again, we're going to pull up our calculator and check and make sure that this makes sense. And so we're going to change our mode to degrees. Be sure that you do that. And then we're going to enter these expressions in our calculator. Now remember that in order to use a cotangent, we're going to have to enter it in as a reciprocal. So 1 divided by tangent of 195. And let's see, that gives me 3.73. And then I'm going to plug in the other side, tangent negative 105, and we should get the same answer. Okay, so let's move on to another example. All right, so our next example says, given that cosine theta is equal to negative square root of 3 over 2, and tangent theta is negative, we want to determine our angle and also our tangent of that angle. Okay, so to do that, what we need to do is we need to draw a triangle. And we need to use the fact that we know that cosine is negative and tangent is negative to help us determine the placement of that triangle. So remember that on your sine charts, that your cosine chart looks like this, and your tangent chart looks like that. So let's determine what quadrant we're going to be working in. We know that cosine is negative, which only happens in quadrant 2 or quadrant 3. We also know that tangent is negative, which also happens in quadrant 2 and in quadrant 4. When you draw your triangle to work your problem, you need to put it in a quadrant that meets both conditions. And since quadrant 2 is listed for both the cosine and the tangent, that is where we will place our triangle. So let's begin with that picture of that triangle. I'm going to draw an angle in quadrant 2. This will be our angle theta. And we're going to make a triangle out of it. Now remember that in order to do a triangle, you want to pull your angle down to the x-axis. And so we're going to draw a line down here. This will technically be our reference angle in here, but remember that our reference angle and our original angle is the same, except for a difference in the sign. So we'll just call this theta prime for the reference angle. Okay, so let's look at what we know about this angle. We know that the cosine is the adjacent side over the hypotenuse. Remember your SOHCAHTOA. So I know that my adjacent side is square root of 3. And I know that my hypotenuse is 2. Now, note that cosine is negative. So the easiest way to deal with this negative is to go ahead and place it on this side down here on the square root of 3. The hypotenuse can never be negative, but as you're looking at moving from the origin across and up, you are moving in a negative direction. So although the length of that side is not a negative square root of 3, we can go ahead and put the negative on there to make things easier for ourselves. Okay, so what about the other side that we're missing? We can use Pythagorean theorem in order to find that missing side. So we can plug in a negative square root of 3 for the a value, and we can plug in a 2 for the c value. So negative square root of 3 squared is just going to be 3. 2 squared is going to be 4. And so subtracting 3 from both sides, we get b squared is equal to 1. Taking the square root of both sides, b is equal to 1. And it is a positive 1 since we're moving up. Remember, you're going to look at it going from the origin back to the left, which is negative, and up, which is positive. Now, the problem asks us to determine tangent theta, so I'm going to go ahead and do that. Remember that on your SOHCAHTOA, tangent is opposite over adjacent. And so our opposite side is 1, and our adjacent side is negative square root of 3. We would need to rationalize that, so we'll multiply top and bottom by square root of 3, which is going to give me a square root of 3 over 3, and we have a negative. So negative square root of 3 over 3 is our tangent value for theta. Now, the other part of this problem is asking us to determine what the angle theta is. Hopefully by this point you recognize the sides on the triangle that we drew as common to that of a 30, 60, 90 degree triangle. And so we can go ahead then and say that this is our 30-degree angle inside the triangle across from the 1. And so if we know that this angle here is 30 degrees, then the angle from the starting point to the terminal side of the triangle must be 150 degrees. So we can say that theta is equal to 150 degrees, or 5 pi over 6. All right, our last example tells us that we're given that cotangent is equal to 0.4 and that theta lies in the first quadrant, and they're asking us to find sine. So this is actually a little bit easier of a problem because we're told which quadrant to put our angle in. We know that we're dealing with a first quadrant angle. So I'm going to go ahead and draw an angle in the first quadrant. And we're going to drop a line down to the x-axis to make a triangle. Okay, so cotangent equaling 0.4. Let's go ahead and write that 0.4 as a fraction. So we know that 0.4 is equivalent to 4 over 10. And reducing that, our cotangent is equal to 2/5. We know by our SOHCAHTOA that cotangent is adjacent over opposite. It's the reciprocal of the tangent. So adjacent side would be 2, opposite side would be 5. And we could use our Pythagorean theorem to find the missing side. So we could say 5 squared plus 2 squared is equal to c squared. So 25 plus 4 is equal to c squared. C squared is then equal to 29. And our hypotenuse would be the square root of 29. The problem asks us to determine the sine. So to determine sine, we remember that sine is opposite over hypotenuse. So our opposite value will be 5. And our hypotenuse will be the square root of 29. We will rationalize that so that we do not have the square root in the denominator, which gives me a sine value of 5 on the square root of 29 over 29.